Hello everyone, my name is Andrew Kim and welcome to the third video of my AP Physics 1 review session. So the third video will go over through the Unit 3 of AP Physics 1, which is circular motion and gravitational force. Now let's first start with circular motion. So this is a classic circular motion example. You have a car or a cart or an object moving on a circular path. Now, first of all, let's think about this situation where the car starts at this position with speed v and moves to this position with the same speed. So again, in most of the circular motion problems that's given in physics 1 level question, always the speed would be constant. The object would be moving on a circular path on the same speed, on same how fast or slow it is. Now, obviously, my first question, did speed change, can be answered that no. The speed is always constant on a circular motion that's given in AP Physics 1. The speed should always be equal to v. It should be constant. Now, the velocity changed is my second question. Well, the answer would be yes. Now, you have to keep in mind that velocity is a vector. It's the magnitude plus the direction. Yes, the magnitude of the velocity is speed, and that was constant. It was, let's say, 5 meters per second. It was 5 meters per second the entire time. However, the direction of this car has changed. It started from here, but then it moved to this position, which points towards up left, not completely just upwards, straight upwards. So the velocity indeed changed. Yes. Now my next question is, then what about acceleration? Is there acceleration present in the circular movement? Well, my answer is yes. Why? Again, in my first video, in my kinematics video, I explained how velocity is the object's ability to change its velocity. Now, does the object have the ability to change its velocity? Yes, indeed, because the object did literally change its velocity. So the acceleration would exist. Then which direction would the acceleration be? Now this is a tricky question. Now let's think about the formula of acceleration. A is equals to delta v over delta t. Delta v is the change in velocity. Now how did the velocity change? Well, initially the velocity was pointing upwards. However, at this point, let's say this is point B and this is point A. At point A, initially, you had velocity pointing upwards, but at point B, later, you have the velocity pointing towards up left. So somewhere like this. Now, let's make it shorter because the two should be the same length, right? Why should they be the same length? Well, the length is basically the magnitude, and the magnitude of the velocity is the speed. And I literally mentioned that the speed should not change on a circular motion in AP Physics 1 level. Now, what is delta v? Delta v is the change in velocity, and change, in other words, is Vf, final velocity, minus Vi, the initial velocity. Now, how do we find the subtraction of the final velocity and the initial velocity? Well, over here, you would have to use vector subtraction. Now, vector subtraction works by head to tail. Or you can also do it by, so head to tail. This is actually really hard to explain, but it's simply how vector systems work. Now, let's shortly talk about vector calculations. So if you're adding the two vectors, then you would have to use parallelogram method, which is basically draw a parallelogram using the two vectors as the two sides and connect the diagonal. This diagonal would be the addition of the two vectors. Then what about vector subtraction? What if you want to subtract this vector and this vector? Well, in this case, it'll be really easy. They're pointing towards the same direction, so the vector subtraction, the result would be just this much left. However, what if the two vectors are pointing different way? Well, in this situation, we use triangular method. Over here, we use parallelogram method. So parallelogram for addition and triangle method for subtraction. How triangle subtraction works is head to tail. You have to move from the head of the vector that you want to subtract, and you have to connect it to the head of the vector that you want to subtract the vector from. That might sound kind of confusing, but just remember this. So if you want to subtract this vector from this vector, then you have to connect the vector that you're subtracting to the vector that you want to subtract from. So in this situation, you want to subtract this velocity from this velocity, because this velocity is the final velocity and this velocity is the initial velocity. So you want to subtract this from this. So you connect the head of this vector to the head of the other vector that you're subtracting from. Thus, the subtraction of the two vectors would point this way, which is slightly downwards and leftward. In other words, if we do the same thing over here, that would point this direction. Now, my circle and everything was so poorly drawn, but technically this arrow should point towards the center of the circle. Now, what this tells us is that the acceleration is pointing towards the center of the circle. In fact, although my drawing is poor, still you can see how this direction, if you move this vector to the object, because acceleration applies on the object, not over here, you simply draw the arrow here to just show how the subtraction worked, but in reality, this acceleration should apply on the object. So if you just move this vector to here, then you can see how the acceleration points toward the center of the circle. Now, the conclusion that we can come up with is that acceleration caused by a circular movement always points towards the center of the circle. So acceleration, which direction? It's towards center of the circle. Now then, which direction would the force be? Because if there's an acceleration, then again, in the previous video, in the second video about dynamics, I explained how acceleration is caused by a force. And the direction of the acceleration caused by the force is the same as the direction of the force. Thus, the direction of the force would be the same as the direction of the acceleration, which is to the center of the circle. And this force that caused the acceleration, that caused the velocity to change, in fact, the direction of the velocity to change, is called the centripetal force, the force that points toward the circle. And there's an opposite direction force called centrifugal force, and this is caused by action-reaction, which I explained in the previous video. So centripetal force is a force that's causing that points toward the center of the circle, and centrifugal force is a force that points towards out from the center of the circle. Now, you can calculate the centripetal force by the formula mv squared over r. M is mass, v is velocity, and r is the radius. So you can use this formula, keep this formula in your mind. And now I'm going to explain about how a centripetal force and centrifugal force react. Now, there are two big cases, but let's talk about a roller coaster situation. Or no, let's just talk about a situation where you have a block tied onto a string and you're spinning this block. Now, what if you suddenly let the string go? What if you are spinning the string, and then what if you just let it go? Where would the block head towards? Well, the block would not move towards the center of the circle, but it's going to fly away. It's going to fly further away. It will move out towards from the center of the circle. Now, what this tells us is that if we start spinning, or to an object that's rotating on a circular path, there's always a tendency, or there's always a force that tries to move out of the circuit, and that force is literally the centrifugal force. However, it can't get out, it can't deviate from the circular path, because you have the centripetal force that's holding this block tight on the circular path. And this centripetal force can appear in various different ways. In this situation, the centripetal force is present by the tension. Your string is pulling the block towards the center so that it just doesn't fly out of the orbit. If you think about a roller coaster, when a roller coaster rolls on a circular path, the roller coaster doesn't just fly out because of a centrifugal force, because you have the centripetal force that's pushing the that cancels out the centrifugal force, and in this case, the centripetal force is present in the form of normal force because the roller coaster trail is literally pushing the roller coaster down so the roller coaster doesn't deviate and just jumps out of the circuit. So centripetal force is a force that holds tight on the object so that the object doesn't deviate from the circuit, and it can appear in various forms. In some situation, it can appear in the form of tension. In some situation, it can appear in the form of normal force. Now, that's it for the circular motion. And now, I'm going to move on to the second part of Unit 3, which is gravitational force. Now, when I talk about this, some people might think, Andrew, you literally explained about gravitational force in your previous video. Why are you talking about the same thing twice? Well, the gravitational force that I talked about in the previous video is a gravitational force that's caused by the Earth, and specifically only Earth. However, now I'm going to talk about gravitational force that can appear in any situation between any objects, because unlike what we normally think, gravitational force is present between any two objects, even between me and the chair, even between me and the iPad that's recording me, there's gravitational force present. Then why am I not being attracted to the objects? Why am I not getting pulled by the object? Well, that is because the gravitational force caused by these small objects are so negligible that it can't beat the friction between me and the floor to pull me towards itself, the object. However, obviously, Earth is massive. It's infinitely bigger than this small chair, and that's why the Earth is strong enough to hold me tight on itself. Now, one thing important to memorize, well, you don't need to memorize this because it's so obvious. Gravitational force only is present in the form of attraction. There is no repelling gravitational force. Now, this seems very obvious, but it's not. If you think about magnetic force, you have repel and attraction. If you think about electric force, protons and protons repel, whereas proton and electron would attract. So in most form of forces, there are more than one direction present. There can be attraction and repel. However, in gravity, you only have one direction, which is attraction. Now, how can you calculate gravitational force? Well, that you can do by Fg equal to, by using the formula mg m1 m2 over r squared. Now, r is the distance between the two objects. To be more specific, it's the distance between the center of the two objects. Now, there might be some questions where it gives you two planets, and obviously, planets have volume. It's not just dots. So you shouldn't use the distance from this point to this point, but you have to use the distance between the center of the two planets. That's one thing to remember. G is a constant. It's going to be on your formula sheet. You have to remember. Now, M1 is the mass of one planet. M2 is the mass of the other planet. That is why the gravity would be greater between me and the Earth than between me and the chair, because the mass of the chair is so low compared to the mass of the Earth. So the gravitational force caused by the Earth is actually, it's important, whereas the gravitational force caused by other objects are negligible. Now, what's interesting is that if you examine this formula, and if you examine, so okay, let's think about this. Then using this formula, we can express the gravitational force between me and the Earth as well. So that would be Fg equals to r squared would be the radius of the Earth, because it's the distance between the center of the Earth and center of me, but center of me is less than 1 meter, so it's negligible compared to the radius of the Earth. So basically this r would be radius of the Earth, g is a constant, m1 would be my mass, and m2 would be the mass of Earth. Now what's interesting is g is a constant, r is the radius of the Earth, which is constant, m is the mass of the Earth, which is also constant. Everything except my own mass is constant. And this everything else, we group them into a simpler constant, which is small g, or 9.8 meters per second. That is why we can express the gravitational force caused by the Earth in the form of Fg equals to mg instead of this complicated thing. Why? Because again, except for your own mass, all the other components are constant. The radius of the Earth is constant, is always the same. The mass of the Earth is constant, it's always the same. And g is literally a constant. That's why you can use this formula, and that's why these two formulas are not different. They're literally the same thing, except for this one is a simpler and a more specific formula that can be specifically used for the gravitational force between me and the Earth. So that's it for Unit 3. Thank you for listening to my review session, and don't forget to have a great day.